Well, okay, we're back after the battery ran out and I had to run all the way back to where I have electricity. I changed hats. This is my Coyote hat, which is a Japanese farm equipment company, but the name Coyote hat is a character name in my novel, and lots of meaning behind that for me. Won't go into any of that anymore. And I've also changed shirts because yesterday I was sewing a shirt. Let's see. Yesterday I was sewing a shirt that used to have a double slit experiment shown on it and attributing strong emergence to that. Well, we'll get into that a little bit later, I hope. The shirt, sewing the shirt and thinking about strong emergence is actually what got me to the point of this epiphany that I had this morning at 5 a.m. It's now almost 2 p.m. So, okay, where I left off was that it was very well done the way the camera cut off just after I accomplished the point that in the many worlds, or in any quantum interaction between particles, the particles, all particles are surrounded by a noise of quantum fluctuations. Virtual particles are just virtual quantum fields. So those particles interfere with the process going on with the particles themselves, the interactions and everything that the particle does. So my hypothesis, or the question to be tested, is whether when you create a split in the worlds, when you've got two worlds after a quantum interaction, whether both of them are affected by those quantum virtual particles causing fluctuations, which could be the beginning or a cause of what I will call mutations from the laws of physics of the previous world before the split. So this is a question that I don't think has any physics answers yet, but it may be that if one is trying to find answers for something like that, that it ought to be theoretically at least able to be studied. They know a whole lot about those quantum fluctuations and what they do to particles. So when the particles interact and split into two worlds, perhaps some ever so slight mutations might just be acting in that process, during that process. They could be really slight. I'm talking about unobservably small, and that's obviously a problem. If you can't observe it, you can't prove it or demonstrate it. But these many worlds are splitting just so frequently that you just gotta, you don't need anything but a very tiny fluctuation to start to accumulate a tiny mutation, say down in the 17th or the 50th decimal place of some quantity like the mass of an electron, or the fine structure constant, or any of these things that we claim appear to be highly finely tuned for life. And I'm going to get a whole lot more into that. But so if we have many worlds, any interaction causing splitting of worlds into two real physical worlds, which may be manifest in those quantum virtual particles that are buzzing around as this interaction takes place. You may actually be able to detect before the quantum, at least theoretically sense some effect before the virtual particle fades away, that you could maybe attribute to the other world, the branch that we can't observe because we got, by our choice, by our observation, we got put in only one of the possible worlds. Okay, so it's a little bit, or maybe a lot, speculative. But the idea being, and the epiphany being, quantum mutations down in the level of the noise, but accumulating by means of what, because, and this is known in physics and quantum mechanics, that what you choose to observe actually affects what you see. And sort of a classic way of explaining that, or at least an example of that, is if you observe an electron, a pair of electrons with that are entangled with spin up and spin down. If you observe the spin in the vertical direction, you will always get a definitive answer. It's either spin up or spin down. If you then take that same particle and try to observe it in the horizontal direction, spin right or spin left, the particle will automatically decide a new answer that is either right or left. Even if you have previously observed that same particle and know that it is that same particle, I think these are called Stirling-Gerlach experiments that you can do by orienting magnets, strong magnets. The electron's been measured with spin up, and then you go and look to see if it's spin right or spin left, and it'll choose completely randomly, and it won't matter at all that it was spin up or spin down. It's just like it's completely forgotten that, because the new interaction creates a whole new split in the many worlds. Okay, let's take a pause here. Let me get my breath.